Video, we are going to be discussing what are called zero force members in trusses. Now, this is exactly what it sounds like. These are members that are part of a truss system that support zero forces. Okay, so we're going to say these are members in a truss in which the force in them is zero. It's nothing, okay? They have no force in them. Now, in some of our numerical examples, when we were illustrating method of joints, we saw that some of those member forces came out to be zero. So the question that we may ask ourselves is, why do they exist? Why do we make a truss in which some of the members don't support any force? It seems kind of like a waste, right? I mean, if you have a truss and you know that a particular member is not going to support a force, it's going to be a zero force member, why even have it there? Well, there's a few reasons why the presence of zero force members would be important to have in your truss system. Okay, so we're going to say reasons for zero force members. Okay, one reason is, put a little asterisk here, one reason is due to temporary construction loading. Okay, so we'll put a little note here, temporary construction loading. So what we mean by this is, let's say that the final truss that's supporting the final loads on your structure is going to have some zero force members at the end of it all. But what about during the construction of it? Okay, what about when you're actually building the truss, or when the construction team is physically putting it together? Are those forces necessarily going to be zero force members during construction? Maybe not. So temporary construction loading, this would have to do with the fact that some truss members may support loads during construction, but not necessarily after construction. Okay, another reason why you may have zero force members as part of your truss system is due to the possibility of unexpected loading. Okay, so we're going to write here unexpected loading. So let's say that under ordinary circumstances, you have a certain couple of point loads on your truss, but maybe you're in a high seismic zone that could be subject to an earthquake. So if you have an unexpected event like an earthquake or maybe a major windstorm, some of those truss members that ordinarily would be zero force members now are supporting a force because you have this unexpected earthquake force happening or an unexpected wind load blowing on your system. Okay, so unexpected loading. And then a third reason for having zero force members would be for stability reasons. Okay, for stability reasons. Now, what we mean by stability is stability has to do with your structure not wanting to move or collapse. Okay, so you may have a structure, and in this case, a truss, in which a member has zero force. However, that member is helping the whole truss stay up, right? It's helping the whole truss not to collapse. So even though it's not supporting a force actively, it is preventing the truss from just kind of collapsing or folding in on itself. So that's what we mean by stability. Now, in a later course, if you're in civil engineering and you take a course you'll later on take a course in structural analysis, we're going to explore these reasons a little more thoroughly. But for the purposes of this class, you just need to be aware of these reasons for zero force members, and we need to be able to visually identify zero force members. So that's what we're going to get to next, and that's going to be our visual inspection criteria for zero force members. Okay, now we have two visual inspection criteria for zero force members, and if you really understand these two criteria, you can be able to look at a truss and pretty much identify which of those members are zero force members. And guess what? You could do that without doing really any calculations. You can look at it and say, oh, that one's a zero force member. Oh, that one over there is a zero force member, without doing any calculations. So let's talk about these two visual inspection criteria. Number one, here's what it says. Now try to absorb what we're saying here. It's a lot of vocabulary. If three members form a truss joint in which two of those members are collinear. What does collinear mean? Collinear means lie along the same line. So you got three members forming a truss joint, and two of those members lie along the same line. Then the third member, which is the one that is not collinear with the other two, is a zero force member, so long as there is no applied force or external support reaction at that joint. Okay? So take a second and really think about what we're saying here. If you have a truss joint in which there is no applied force and also there is no external support reaction, and that truss joint is formed by three members in which two of them are collinear, then the third member, which is the one that's not collinear with the other two, is a zero force member. Okay, so that is one of the visual inspection criteria. We'll call that visual inspection criteria number one. Okay, now let's look at visual inspection criteria number two. If two non-collinear members form a truss joint, both of these members are zero force members, so long as there is no applied force or external support reaction at that joint. Okay, so let's kind of dissect this. In this criterion, I guess it's a singular. In this point, if you have two members forming a truss joint, and that joint does not have any applied load, and it also does not have an external support reaction, and those members are what we call non-collinear, that means they are not lying along the same line, then both of those members are zero force members. So these two criteria you need to really absorb and make sure you remember them. Okay, you basically need to memorize these. Now we're about to in the next couple videos we're going to do some examples where we're going to illustrate these. Now here's another point of this. Okay, these two criteria may be used together. Okay, so what we're saying here is we may have a truss in which we find some zero force members according to criteria number 1, and then once we have recognized those zero force members according to criteria number 1, then we may be able to apply criteria number 2 to find more zero force members, and vice versa. Okay, so these two criteria may be used together. So we're going to see some examples illustrating that in the next video.